In this course, we're going to do a lot of integration techniques, and we're going to start with integration by substitution. All right, let's start by looking at a derivative that's related to our integral. We're going to use the chain rule here to take this derivative, bring down the 6, subtract 1 from the exponent, and multiply by the derivative of the inner function. That would be 2x. All right, let's just simplify this. 6 times 2, so we have 12x. X squared plus 10 to the 5th. So there's our derivative. All right, so from this we know that if we integrate, if we go the opposite way, we should get what we differentiated. So let's integrate 12x, x squared plus 10 to the 5th, and we get what we took the derivative of. All right, so that's just going in the opposite direction. Now this integral is similar to this one, just the 12. The 12 is missing from our integral in number 1. All right, so we see it should approximately be this, but we just have to figure out the constant. All right. Okay, so what we're going to do is we're going to do a technique called U substitution in order to rewrite this integral in terms of another variable, okay, variable u, that's the variable that we're going to use, and that will turn this into a simple power rule integration. All right, now how do we know? What are we looking for? Well, what are we looking for to realize that it's appropriate to do what we call a U substitution? We're looking for the following. We're looking for something that looks like a chain rule derivative. All right, now this looks a little bit like a chain rule derivative. All right, we have an inner function, and the derivative of the inner function is almost on the outside, except we're missing a constant. So that's the situation we look for before we do a U substitution. All right, now what we do is we set u equal to the inner derivative. All right, so, okay, let's do this on another screen. All right, so we're going to set u equal to the inner function. This is the inner function. And we'll put u equal to x squared plus 10. All right, now we have to substitute for dx as well. So to figure out what dx is, we differentiate both sides. Differentiate u symbolically, write du. And on the right-hand side, differentiate the right-hand side. Derivative of x squared is 2x. And we'll write that as 2x dx. Okay. Now in our integral, we have an x dx, not a 2x dx. So let's divide both sides by 2. All right, using what we have here, we can now substitute for all the pieces in our integral. So let's do that. First, for x dx, we will substitute 1/2 du, okay, because that's equal to x dx. So let's do that. Okay, so I'm going to cross this off because we did our substitution. And now what's left? This is what's left, x squared plus 10 to the 5th. Well, for x squared plus 10, we're substituting variable u, so that would be just u to the 5th. Let's rewrite this with the 1/2 on the outside. And what we did was we turned this integral into a very simple integral where we can use the power rule. So now we can integrate using the power rule. All right, that's equal to 1/12. And now we're going to substitute back. Remember that u is equal to x squared plus 10, so we're just going to put that x squared plus 10 back. And that is substitution, integrating by substitution. Okay, number 2 is also a candidate for integration by substitution because we do have an inner function, and the derivative of the inner function is 3x squared, and we have x squared sitting on the outside. All right, that is the derivative without the constant. So that is a good, this is a good candidate for integration by substitution. And we put our variable u equal to the inner function, and then differentiate both sides. Then we solve for what we have in the integral. We have x squared dx, not 3x squared dx. So we'll divide both sides by 3. All right, and now we have all the pieces and we're ready to do our substituting. So for x squared dx, we're going to put 1/3 du, and I'll just right away put the 1/3 on the outside. So that took care of our x squared dx. And now for x cubed plus 5, we're going to substitute u, so we have 1 over square root u. All right, now we'd like to integrate this, and what we'll do is first we want to use a power rule, so let's change this to a power that we can rewrite this as u to the minus 1/2. So let's do that. And now we'll just do the power rule. Okay, add 1 to the exponent. Minus 1/2 plus 2/2 is 1/2. Divide by 1/2 now, or multiply by 2. All right, so we get 2/3 u to the 1/2 plus a constant. And let's substitute back u is equal to x cubed plus 5, so that's 2/3 x cubed plus 5 to the 1/2 plus a constant. All right, let's do a check now, because now if we differentiate this, we should get our integrand. So let's do that. Here's our check. All right, right here. Let's do a little check right here. Okay, so we want to differentiate. Let's do 2/3 x cubed plus 5 to the 1/2. And we just want to differentiate that. Okay, so bring down the 1/2. 2/3 times 1/2 is 1/3. And now 1/2 minus 1 is minus 1/2. Now the derivative of the inside is 3x squared. Okay, these 3's cancel. Let's put this in the denominator, and we get x squared over the square root of x cubed plus 5. All right, so that's our check. That's correct. We got the integrand back, so that's correct. Okay, so here again we have an inner function. X squared is our inner function, and the derivative of x squared is 2x, and we have an x here on the outside. So again, that's a candidate for u substitution. We put u equal to the inner and differentiate. Then solve for what we have. We have x dx. Okay, so using this, we're going to start substituting. All right, so for x dx, we're going to put 1/2 du. We'll put the 1/2 on the outside. Okay, so we got rid of x dx with that substitution. Now secant squared x squared, we're going to write secant squared, and instead of x squared, we're going to put u. Now remember that secant squared is an exact derivative. That's the derivative of tangent. So this is equal to 1/2 tangent u. All right, now substitute back. U is equal to x squared. That's 1/2 tangent x squared plus c.